Preparing to live stream the meeting.
Oh, this is a different message here. The content of this meeting is being sent to a third party.
Oh, God. Who could that be? One of us?
YouTube.
Five on the screen.
No, I got live stream. Mine says live stream.
Yep, you're on.
It says live. It says we're on YouTube, and it is time once again, ladies and gentlemen, stargazers, members of the club, for the SBAU Astro Hour. We're proud to be here. It's a 1 hour weekly vlog. We do live every Monday morning, 11 to noon, for the Santa Barbara Astronomical Unit, your south central coast of California's longtime telescope and astrophysics club, centered up at our beautiful Museum of Natural History in Mission Canyon. I'm your host, Ron Herron, former DJ, vice president 5 years now, up for re-election this month. In fact, this week, along with the man to the left of me on my screen. We'll talk to the gang here in a minute. And I do learn a lot from these very knowledgeable friends and comrades of mine in the SBAU. I'll introduce you to the Whole Brain Trust in a moment. Watch us on YouTube. It's like what you see from the sun, 93 million miles away, is like 8 minutes old. You're seeing us 20 seconds old on YouTube. And doggone, let's check out what we're going to talk about this week. The morning star Venus is out there. And a beaver moon. What is a beaver moon? Well, we're going to check on it. Yeah, Cassiopeia is the winter queen. She's up with a couple of its stars. We're going to go there. Got an open star cluster as well to talk about this hour. The wild duck cluster has not flown south for the winter, and they're in Scutum, which sounds like a terrible medical term I don't want to talk about. Your Lemon comet, its status, and Saturn's moon Iapetus is among our topics this week. It's got something very strange on it happening at the equator. We got pictures. And speaking of pictures, James Webb's come through with some beautiful new nebulae. We're going to land on an exoplanet, at least with a picture, and get some description of that. And a dinky little satellite of Mars called Phobos. We're going to travel with it. We also have our silly science cartoons, but let's meet the gang. Still with us after all these years, Jerry Wilson, married to Pat. Hi, Jerry. President Jerry, up for re-election. So far, nobody's declared against you or I. However, we got some changes in the other two posts, the officers we're going to kick around Friday night at Fleischman Auditorium. Chuck McPartland is here. He's married to Pat. He is our outreach coordinator, in charge of most events. Pat's going to possibly take on an additional duty along with her merchandise manager stuff this new year. We have on the screen Tim Crawford, resident lens and telescope expert, longtime SBAU member, and I think co-founder of the Telescope Tuesday workshop. His wife is Karen. Good to have you with us, Tim. Tom Whittemore is on board.
Morning.
There he is, at least the top of his head. He's married to Maureen, editor of SBAU's incredible monthly newsletter we just got. There you go, close up. Nice not licking up your nostrils this week there, Tom. And a darn good copy of our...
Don't be so nosy.
Yeah, that's right. He'll probably have some reports on spotting the moon. Boy, I saw it this morning when I got up, and It just seems like it just happened a week or so ago. Dang it. It's getting very fast these days, gentlemen.
It moves around.
Yeah, it does, I guess. And a beaver moon, we're going to find out why it's called that. But first, a record week of having President Jerry's forwarded silly science cartoons. I hope I can keep up with them. I counted at least 10, and I doubt we'll get them all on the screen. But some of these are very thought-provoking and funny, and some of them are like groaners. Like a bit more. Here we go. This... Where would this be? The aliens. Has this ever happened to you? You wake up and there's a collar around your neck?
Not that I noticed.
Hours later, when they finally came to, Hal and Ruby groggily returned to their yard work, unknowingly wearing the radio collars and ear tags of alien biologists. Little E.T. did that show. Okay. And this is this is way back. This is one of the recent ones. Future game show, Facts Don't Matters. This is similar to the gang that are, your family around the table for Thanksgiving. You have Uncle Walter on one side voting for Trump and the other side voting for Biden. And the MC in the future game show goes, sorry, Arthur, your answer was actually correct. But Paul shouted out his opinion louder. And so he's going to get a point for that. And an extra bonus point also goes to Susie, as she was offended by your answer.
Oh, God.
Much the way politics is these days, and religion isn't far behind. All right, this is interesting. That seems to have put us in the Andromeda galaxy, because last time I looked, we don't have a picture of our galaxy, but don't take this seriously. You were here and you were insignificant.
And the other arrow should say the bathrooms are here on the other side.
Yeah, right.
Is that the point of the joke?
No.
Here are some aliens trying to indoctrinate a kitty cat, and we all have cats. And here's the weirdo bringing in the feline, says, we brought this back as a gift, Your Excellency. Makes hilarious videos. You can sit and watch cat videos. You see the one playing the piano?
Yeah.
Okay, let's go to another kitty cat one. You almost
Where I don't see the piano.
Well, no, but that's one of the best video cat videos you can watch.
Oh, that one you're referring to the video. Yeah.
Yeah. Well, I sit and watch it for hours with my grandchildren.
Yeah.
This one I wanted to comment on because, here it is. Paraphrase the descriptive line from the Alien movie poster. In space, they can't hear you scream. But doggone it, they can sure hear your damn leaf blower. In fact, there's the alien backyard coming down. Hey, in space there is no sound, but except for these, we can still hear those damn leaf blowers. That would be who was that English guy that actually brilliant? I think passed the law.
That's it. That's it.
That's him on the left there. Yeah,
I was just going to mention that, Ron.
Okay, Calvin and Hobbes take on math. Now this is interesting. 4 pecks make a bushel, plus a case of mononucleosis. He's at his desk, and Calvin says, a bushel is a unit of weight equal to 4 pecks. And he turns to the tiger friend and says, what's a peck? And the tiger says, a quick smooch. Sure enough. You know what he says? I just don't understand math at all. I'm sorry. Got mono from the girl. Now here's some Indians gathered around. I don't like doing these immigrant raids to you guys, the immigration, but it's their side, the original inhabitants.
There's a turnaround.
Yeah. Now here's a statement from the world of science. Just warning, if you're buying a watch on Amazon, I learned the hard way that if it says you can swim with it, it only applies if you could already swim without it before. Don't take this off yet. Remember the joke about the guy who had a construction accident, injured his hands, and was having them repaired? He asked the doc, when I'm ready, doctor, will I be able to play the piano? And he said, yes, you will again. Oh, that's funny. I never could before. Similar to this joke. Okay, what do we got here? All right. The Earth gets some cream, new anti-aging cream, because it's, being old is not so bad. Oops. And she drops it on the Earth, and doggone, Mother Earth gets a nice, clear complexion or something.
I've seen goes back to Gondwana land.
Yeah. She just see all the continents are apart here, and now they're all together here, like it was in the Earth's youth.
Oh,
that's one big, as I never know whether the recent one was Pangea or Land. I guess
I didn't get that. I was looking at
I didn't get it either. Yeah, now I got it.
I see. Mother Earth reunites all the continents. All right.
Ron, I remember that watch one reminded me. I think it was. Remember the watch? They said it takes a licking and keeps on ticking, and they put it on live TV and they strap it to an upboard motor. And they said, "Watch this."
Yep. Right. Long time ago.
They turned it off, and all these parts were floating in the tank.
You know what I've noticed about all of my friends that are our age, and I'm going to ask you right now, have you stopped watching the afternoon news just because of commercials? Everybody's got streaming live shows they pay for, and they don't want commercials.
Oh, it's heavy. It's like I interrupt the commercials for a little bit of the show.
Well, yeah, we all grew up watching. Walter Cronkite and John Chancellor and
thing is that we still watch the evening news with David Muir here. I think it's ABC. And I got so because I was raised with commercials and TV, Pat asked me, what was that commercial about? And I don't remember. I just totally blank when the commercial comes on.
Yeah.
Yeah.
Anyway, this picture I snuck in. It wasn't in the handouts, but we talked about it last time that this periodic table existed, and I sent it to you guys.
Yep.
Yeah.
Commented.
So it's got
Did you
a
get-
symbol for where each of these elements came from. Some of them came from multiple sources. So
But right between
Go
lithium
through.
between lithium and carbon, I think, are the only two elements on there. I think it's right in there that were
Yeah.
made by neutrinos. Or is it neutrinos or
Cosmic rays.
cosmic rays? And my question to you when I sent it back, Mr. President, was, are they made in the stars, but by cosmic rays, but not by
Wherever they are, they're made by being hit by cosmic rays.
What is that? Beryllium and what's B? Is that boron?
Boron.
B is beryllium.
Yeah.
BO. This year's
Boron.
B, that's boron.
Yeah.
Well, my question still remains, how in the world do we get so many of the atoms layered so that we can actually see it and make something out of some of these strange
Because they have
elements?
different masses. And when you have gravity, things segregate by mass.
Mhm.
Is that what it is? Because apparently
Well, that's a very long question to answer. So
Yeah.
let's move on.
it's going to require a whole show about it, you guys.
Yeah.
Is that our moon? Who took this?
This is a picture, a nice picture taken in a previous year of the Beaver Moon over a lake in Massachusetts. So
Yes.
this is just a picture of the full moon.
So
And seasonal changes here. It's the Astronomy Magazine claims that it is the Beaver Moon because this is probably the time when beavers come out.
really? Cold as it
Or
is,
no, the beavers go into their lodges to spend the winter.
we should put a Davy Crockett hat on a full moon. Tom Whittemore was out photographing it. Did I come in on your
No,
coverage?
no.
Oh,
No,
you just,
no. Showing it through a little telescope to some dinner guests on Saturday night. Yeah,
Oh.
I don't do photography since Westmont, but it was really pretty. The moon was nearly full Saturday night, and there was a lot of just beautiful craters on the south part of the moon. You could see
yeah.
in great detail, just great detail.
love a beaver moon.
Yeah, the moon was full this morning at 1 o'clock. We're
Yeah.
we're past the full moon. It's now waning.
Right. And I was just going to mention, when we take Wally out in the morning, we saw the full moon, basically nearly full moon setting. It's in Gemini, I think, because it had a really long arc going over the top of the sky. Really pretty. Okay.
Well, this is not a blue moon because today happens to be Monday, the 27th of November, and it takes 28 days, right, to go from full to full.
Yeah.
This is program number 145, gentlemen.
Yeah. No, the phase of the common moons is 29.3.
What was it, 29 days?
Yeah, that's the phase cycle, right?
Okay, yeah, we get 30-day months, which is a
Right.
little stranger.
So-
We should have 13, I guess, couldn't we? Or 12 and a half? Well, never mind.
Yeah. What,
Well,
Chuck?
never-
About maybe four blue moons in 1 year at best.
With the new description of blue moon, yeah.
Okay.
Yeah, the old one's more restrictive, rarer. So anyway, with the full moon taking away or flooding the sky with so much light,
Mhm.
looking for faint fuzzies is not an option right now, in my view, or taking photographs.
Yeah.
So we're going to look at star clusters tonight for
Yeah,
our
I was
deep
gonna
sky objects.
Mention, Jerry, that in spite of that nearly full moon on Saturday night, the Pleiades still came through my little telescope. It was pretty nice. It dazzled a lot of folks here. It was pretty cool. Yeah, you couldn't get
Jerry?
any velocity. There's no way.
Let me mention we got Chuck Watson on with us, Jerry, and I don't know who. Someone always comes on and says Meal of the Kraken. Good morning. I don't know who that is. Maybe Mary. I'm not sure. But we got a couple of people watching with us today.
Okay, good.
Well, how you doing, gang? Good to see you. Remember Friday night, we got 3 of our own delivering talks. Okay, let's go up to the Wild Duck. They haven't flown south.
Okay, this is the western sky. let's see, is
Yeah.
this the western sky?
Yeah,
Yep.
that stuff's going away.
There it
Yeah.
is. Yeah.
This will be low in the southwest.
Yeah,
It's
this
gonna be
is
low. Yeah.
this is early in the evening. This is 6 p.m. So this is the last shot. So
Yeah.
Astronomy Magazine led us to the wild duck early in the evening, and then there'll be an early morning shot next. But the wild duck cluster is this clump right here, M11, in the constellation of Scutum,
Mhm.
and a very descriptive stick
Yeah.
figure here.
Go to the doctor this weekend and have my scutum checked out. Never mind. Shut up.
Mhm.
Yeah, Scutum's the shield, Ron.
Oh, is that what it is? Okay. Well, it sounds dirty to me. I'm
It's
sorry.
Sobieski's shield, right? Scutum
That's right. Good
Sobieskana.
Polish
Yeah.
boy.
Why do they call it wild duck? Does it look like a bunch of V-shaped
We'll
ducks?
get to that here.
Here you go.
Now it's supposed to be, to the naked eye, or not the naked eye, visually in a telescope, it's supposed to be a V shape, like ducks flying, in formation. And I tried to find a good representation of that, and there's a jillion photographs of this online taken by everybody from I haven't seen a JWST yet, but the Hubble and up to amateur scopes, and none of them really show the V.
No, I get actually.
This was the closest I could get.
Okay.
Because
And I think that description dates back to the
Smith?
English vicar that was the observer
Yeah.
of open clusters.
Wasn't it Smith?
Smith, Smythe, something like that. Yeah.
Mike,
Yeah.
I think you're right, Chuck, because actually we had a observer with us out at Westmont one Saturday,
Yeah.
and
Yeah.
I mentioned this V, and,
Yeah.
and she says, "I just don't see it." I was going, "Well, wait, it's not really a V. It'll look kind of just like, to me, it looks almost like a parallelogram or a box." And she goes, "Oh, okay."
Yeah.
Every time somebody says it's a V, they don't see
Yeah.
it.
If you sort of block out these bright stars right there, then I can get a V up here.
This is
Okay.
also known as M11.
Yeah.
This is
Yes.
Messier's 11th object.
Okay, gotcha.
Now you're star hop, Jerry. I didn't understand, but this summer when we had that really nice night out at Bacara, we found a way to discover where this was. I always had trouble finding this, and I think it was Lambda, and there's another one on your chart that had Alpha on it. I think it was from another Scutum, I think, but it's almost halfway between those two stars, and that's the way I found it. Now see the Alpha below right
Alpha,
there,
and then
the
this
one above
one's not labeled yet. Oh, this one?
Yeah, I think that's Lambda.
6, yeah, it's Lambda, 16 Lambda.
On a really nice night like we had, it's the first time that I went kind of halfway between, and it's the only time I found it easy. Otherwise, I kind of really frustrate customers by just not finding it, trying to star hop it.
Well,
Need some setting circles.
Yeah, exactly.
Can I ask a question connecting to the full moon? Which are harder to see when the moon is full, the stars or the clusters? Seems to me a cluster, which is nothing but a fuzzy patch, right? Really, in your lenses, doesn't really show a lot of internal stars like your Altair and Vegas and Denebs and.
Well, that's a subtle question. Good, but subtle. If you see it with your eye as a faint fuzzy, then you're not going to see it well with the full moon.
That's why I'm wondering why we're on a cluster rather than a star.
Open clusters show up better than globular clusters, but open clusters, the more open they are, the easier they are during a full moon.
Well, and also, Ron, this is early at night. This is 6 o'clock at night, so you still have a chance. I think that the M11 is about 25 degrees.
Yeah, about that.
Yeah, and so it's not real high, but it's high enough that you could probably see it, and the moon still hasn't risen, I think.
So the moon, even though it's below the horizons, doesn't affect the sky we see. It's dark enough until the moon rises, and then it floods the sky.
Well, especially when you're looking to the west like this, because the moon's going to be rising in the east, and you get less of a
So
all this. Go ahead.
Yeah, you're going to see. You're going. Go ahead. I'm going to just stay.
All this week, we're going to get increasing slices of darkness right after sunset,
right,
as the moon rises later and later.
Yep.
But this morning, 1 o'clock, the moon technically rose as the sun set and set as the sun rose.
Can you give me a basic definition, if it's possible, of a star cluster, an open cluster, what's the other one?
Globular.
Globular cluster. What's the difference?
There's only two, globular
Those
and
two,
open.
globe and
Yeah,
star.
globular is obviously a little ball, and open is anything else.
But the stars within both of them are pretty much orbiting around each other, aren't they?
No, no,
They're not. They're just all cruising along in space like a
no.
bunch of geese.
They're all in an individual orbit, orbiting around the center of the galaxy.
And,
So
and
that's why open clusters disperse
And,
as
and
time goes on.
think of the globular cluster as a snowball of stars.
Right.
I thought some of them had black holes in the middle of them.
They do.
They do. Yeah,
But
globular is from the word globe, like a globe.
Yeah.
Oh,
I always tell people it's like a snowball of stars.
And globular clusters are older stars, and they tend to be in those really large globular accumulations, whereas open clusters are young stars loosely gravitationally bound, and they can be much more diffuse looking.
Yep, exactly. Exactly.
Just seems to me there's so much rotation in space. There's the solar system where the planets orbit the sun and the moons orbit the planets and the binaries orbit each other and all the stars orbit the black hole in the center. Why wouldn't these little groups of stars orbit each other?
Well, in globulars, they do. They orbit a common center of mass in there, but it's like it's not an organized thing like a disk like you have on a spiral.
Yeah,
it's just randomized. And if in an open cluster they do, but they're moving much more slowly. So they do orbit whatever their center of mass is, but it's a much more slow process because they're so spread out more.
So it would be the ultimate star system, starting with binaries, which is 2, and trinaries, which is 3, and maybe there's quadraries or quadranaries, and then it gets up to dozens or thousands, and we got a cluster, right? But it's basically the same process.
I have a question then. If we're looking at an open cluster, Chuck, is it basically all at the same distance? Because aren't some clusters stars superimposed upon others in the background?
Right. You can get clusters superimposed on clusters farther away, and you can get foreground and background stars.
Okay.
But in a general sense, they're at a similar distance. They have some extent.
Okay. Like the double cluster.
Yeah, the double cluster is 2 at slightly different distances.
right.
Okay.
Double clusters. Oh dear.
They're up on top, Ron. They're up on top there in the picture.
Yeah, 884 and 869.
Yeah, that's
Right
them.
there.
Oh, there's
Two open clusters right next to each other.
Mhm.
Yeah.
You suppose the clusters are orbiting each other?
No,
They're
No,
not.
they're far enough apart.
Yeah, and they're also like each cluster is the size of a full moon. If you put your little pinky finger at arm's length, that's the area of the sky that it would cover, and the distance between them is another half degree, another full moon. So,
But in your scopes, gentlemen, you can see individual stars in these clusters.
Yes.
Oh my gosh. Yeah.
they're beautiful.
yeah,
Good night.
One of them has a number of red giants in it.
You can see these with your naked eye too.
Yeah,
I think it's eight. I think 869 is the one with the red giants. I'm not sure of that, but I think it is. And the double cluster, oddly, was not a Messier object.
Yeah.
And
How did you miss that?
are any of the stars in the clusters prominent enough to get a name of its own?
Virtually every star you see has got a name, but they're not memorable.
Yeah.
In the Pleiades, in the Pleiades, the individual stars
That's
do
right.
because people can sort of pick apart the Pleiades. That's an open cluster.
Well, that's only 7 that we can see, right?
Well, some people can see up to 13, depending on the conditions.
But it's part of a ball of hundreds.
No. It's part of it. It's an open cluster, so it's not a ball.
Oh, okay. It's an open cluster. Got it.
Now, binary, Ron, a binary, and I'm not sure all Mach is, but it's in a true binary, those are going to orbit each other.
Yeah.
Those stars that they've discovered more or less in the last century or so get a telephone number. They don't get a name. Like
Yeah, they really do.
They get multiple catalog numbers depending on who studies them.
Neil deGrasse Tyson's title and all those telephone numbers in space, right? Okay, very good, Mr.
And
President.
Algol here, that's our next subject, is could be up to a 5-star system.
Oh,
Okay, what do you call that?
A
Yeah.
multiple star system.
Oh,
yeah. Algol. Here we
A
go.
handful.
Yeah.
Now, to the naked eye, Algol, I think, is called the demon star.
Yes.
It's a variable because some of its components eclipse each other.
Right.
And so we tried this last month or week before, but we didn't get the timing right. So we're trying again. The object here is to visually spot Algol coming up from its dim stage to its bright stage. And you do that by comparing it to Mirfac here, because when they're both bright, they're both the same. With
Well,
this
Mirfac,
one,
I think, is a little bit brighter.
Okay.
Almach is the usual companion star or comparison star.
over here.
Yeah.
Yeah. Okay. Well, Astronomy Magazine had it comparing Mirfac to Algol. So, but yeah, any of those will do. But the minimum of Algol is a famous timing thing. It's charted. And around this time, the minimum for Algol on November 27 is at 1:33 p.m. today, Pacific Standard Time. So that's in the afternoon. It's a 10-hour dark or minimum phase.
Well,
and assuming it's
the minimum is about an hour on either side of that number.
okay.
The whole phase of it dimming is a 10-hour cycle.
Huh. Definitely sound like Arabic names.
Yeah, that's where we get the word ghoul.
Ghoul?
Yeah, it comes from Ras Al Ghul, the head of the demon.
Okay. Okay. Well, we'll give up on that. I see an error in my logic here.
Yeah, the next time we get a good minimum, well, if you're a little bit of a late night person, is December 9th.
Yeah.
At about 10 minutes to 1. And then December 11th at about 9:38 p.m. So that's a little more accessible.
Okay.
And then December 14th at 6:27 p.m. And then for New Year's at 11:23 on New Year's Eve, it's at minimum. So that'd be a good sort of New Year's welcome the New Year thing to do.
Well, while we've got a trend going here, I think we'll be talking about the minimum on December 9 next week.
Okay.
Okay.
Huh. Minimum. Sounds like cockpits of airplanes when they're coming into land. The voice goes minimum. I don't know what that
It
means.
starts out at 100.
It says 100 feet.
Yeah.
Actually, it
Okay.
starts
Now,
out-
as advertised, this
Okay.
is 5:00 in the morning, tomorrow morning,
Uh-huh.
and we see here Venus.
The morning star.
Hope that didn't break anything.
North of Spica in Virgo at 4 a.m.
Yeah.
Eastern
So
Standard
this is
Time.
Virgo. There's Porrima, Spica, and Venus is now a crescent at what is it, about 67% illuminated crescent.
Wow.
Over 50%, I thought it would become gibbous, but the magazine says crescent.
How could it be a crescent if it's more than 50%?
Yeah, exactly.
Right. So anyway, it's at about the halfway point and it dominates the morning sky. So it's easy to see. You can look at it in your telescope. Preferentially, you would want to look at it at night before sunrise, but keep tracking it until the sun rises. You can see Venus in the daytime real easy if you can find it. And you get a better view of the shape. At night, it's so white and the sky is so dark that in a telescope, the glare of the contrast really takes away from looking at the phase. You get a much better view of it and picture of it during the daytime.
Now, Jerry, what kind of filter could we use to actually get a better phase on that? Just maybe a
Neutral density.
Neutral density. Okay.
Yeah, a moon filter will help you.
Okay. Okay. Yeah.
If you really want, you get, well, of course you can't see ultraviolet, but that would be your best view.
Yeah, if you want to see to the surface.
So
Clouds.
neutral density sounds like a really good idea. I'm gonna try that next time.
If I could bring up a more practical aspect of Venus, isn't NASA sending some sort of a probe there in a year or two? Aren't we going to land there?
Venus, they're designing different, or they're studying different options for how to get there. And one of the options they're looking at is how to float in the atmosphere with basically a blimp-like structure.
Instead of hot air balloons, they're called hot CO2 balloons, right?
No, it would be a helium or hydrogen balloon.
Helium or hydrogen. Well, hydrogen would go like that, wouldn't it? With icebergs all over.
It's not that hot up above the clouds.
Really? Unlike on the sun, where it's the hottest of all during the corona.
Well, yeah, hottest, but you wouldn't feel it as much just because it's so tenuous.
The atoms are just going crazy, aren't they, out there?
Another thing they were looking at on Venus was making a purely mechanical lander, or largely mechanical, because electronics have so much trouble with the heat. But of course, it makes it real hard to talk to it if it's mechanical. So,
well,
it cracked me up. Recently, I was watching a movie on Netflix called "See You on Venus," where it was a big romance, and this girl was talking about what a lovely planet it would be to go visit her. Well, she was alluding to that, but I thought, oh yeah, raining sulfuric acid, nice place.
Yeah.
Mr. Spock, which was Leonard Nimoy, came from there, didn't he?
No.
Wasn't he Venusian?
Vulcan.
Vulcan.
Yeah, Vulcan. I guess I got my signals crossed on that. Be not Vulcan. Fascinating stuff, Mr. President.
Okay, well, in the morning sky is also Coma Berenices.
Wow.
They're Berenices comb.
Her hair.
Hair?
Mhm.
Okay.
Coma is hair, yeah.
Coma, okay. So up in there is a very open cluster called the Coma cluster, but also called Melat 111.
Oh,
You can't find in my planetarium software. But one of the astronauts on the ISS took a picture of this. This is Melat 111, or the Coma cluster. It was taken by Donald R. Petit on Expedition 6 from NASA's ISS. He was the science officer on board.
And you can see some sky glow or aurora down there in the lower right.
Something. Now, it depends on the camera he took. Some of these cameras, like Canon, is famous for having amp glow inside the camera, because cameras were not made necessarily for taking pictures the way astronomers want to take them, of very dim objects under dark conditions. And every time you have an electronic gate, meaning a diode or a transistor, they are both a detector and an emitter when there's current running through them. So some of the early Canons were made with, and I had one that was made with out shielding for the amplifiers. And so you could get these, one of them, Tony Hallis called it the green river of green light that floats through the frame. And so they've especially made shielded versions now for astronomy, the 20DA for astronomy, and now there's the what is it, a 16DA, and Nikon has followed suit with a special astronomy version of their Nikon camera. But it could be Aurora, could be night glow too.
I missed the very beginning of this. What are we looking at? A cluster?
You're looking at an open cluster looks to the naked eye. This looks like a faint fuzzy, but when you look at it with a telescope, and of course the ISS is much closer to it. That was a joke. That was a joke. So this was taken by an astronaut aboard the ISS, looking out the window.
Well, what would the James Webb picture look like? It'd be even better, wouldn't it?
Well,
I
it's a
don't think-
narrow field of view. You'd see one or two stars.
Infrared, right?
But Jerry, for visually, would we look at something like this with binoculars only?
I think no, it's a naked eye object. Under real dark skies, it looks like a faint glow there, but you don't
Oh.
see individual stars. They're too faint.
But it's very wide, so yeah, binoculars would be a good instrument.
Yeah, that's where to start.
Okay.
Question about distances. Average distance in a cluster like that between stars would be less than us and Proxima Centauri.
No, you can get star clusters that are very big.
Well, we could be at a star cluster
We were
We
once.
are.
We were, yeah.
inside the Milky Way, where there's a bunch, all those. Well, wait a minute.
There's something called the Ursa Major Moving Association, which is most of the stars in the Big Dipper and Sirius and Procyon and a couple of other stars. And we share a motion with them through space around our galaxy. So the idea is there was once an open cluster, but now it's kind of spreading out.
Right.
Wow, the North Star would be a
No, Polaris is in the Little Dipper.
Oh, I'm sorry.
Right.
Wow.
You know, and
Cluster-
Sirius is kind of on the other side of the sky from the Big Dipper.
Okay. Fascinating stuff. I love these trips through the galaxy, gentlemen.
Huh. I think I'm missing a couple of photographs here.
The Lemon
It
Comet.
did flash by.
Yeah.
You're hitting arrows for left and right,
No,
up and
no,
down.
the Cassiopeia one.
Oh, that Cassiopeia cluster did flash by. It's the little small one with in the big
Yeah.
circle.
That NGC
There.
129. That 129 we're
Yeah,
talking about.
we'll do this. We'll pick up
Uh-huh.
our stumble. This is a very small open cluster, NGC 129. Good, yes. And this is a handmade drawing by a fellow in Europe,
Really?
or EU, I think, starobserver.eu.
Yeah, that's European Union.
Right. And so this is a very small star cluster. It's only got about 30 members in it, 30 stars. It's very near the Heart Nebula.
Hmm.
And this is the Heart Nebula. So can you pick out that NGC 129 in this picture?
The top,
Right up there?
right
That's
there,
it.
yeah.
Yeah,
Oh,
that's
you know,
it.
Jerry, what I think happened, since you sent me the images, I went to see if I could recover the one you wanted.
Yeah.
And it's, Markarian 6 and 5.6 Markarian 6. But when I open it up, it's like just the EXIF file from Adobe of a picture, and it says Adobe Photoshop CS4, Windows 2023, and a bunch of gobbledygook.
Okay.
But very little content. So it's like it only got the data, the metadata from the picture. So that's what
Okay.
happened with that one.
Okay, I must have saved it wrong. Okay.
This is all part of the big W in Cassiopeia, though, isn't it?
It's in that area of the sky. Yes, part of that constellation.
Okay, inside the W, find magnitude 2.3 Calf Cassiopeia, or which is Beta Cassiopeia. You know, that's a word that I've never seen that has 4 vowels in a row. Cassiopeia, P-E-I-A-E at the end. How do you pronounce that?
Cassiopeia.
Yeah.
Tom would have a better view on that. You're more of the Latin and
Yeah, well, it's the possessive case of Cassiopeia. So
Beta.
it means of Cassiopeia.
Okay, but it's somewhere in the chair or the W, whatever.
well, there's a big area around that's part of this constellation. Yeah.
Okay. Interesting. 129. And then there's another star called Markarian 6, somewhere in another cluster nearby.
No, that's the same cluster. That's another name for it.
Oh, it is. Markarian.
Oh.
Or is Markarian 6 the nebula? I don't know. No, that's it. It's the cluster is also called Markarian 6.
God, for a second there, Chuck, I thought I had you. First time I've ever I don't know.
Yeah, give that one up.
Never heard you say I don't know ever.
Oh, I'm sorry. Wait a minute. Stock 7 it's stock 7.
What does that mean? Where are we all of a sudden? I'm lost in space. Danger, Will Robinson.
Those must all be names for the same thing because it looks like
Yeah.
this narrative came from several sources or used several names for it. So actually, they're all the same thing. NGC 129 stock.
Yep.
Although then it says, well, okay, stock
Oh,
7.
it's stock, you're right. Stock 7 and Macarian 6 are other names for that
Oh,
on beauty
interesting.
for this
Yeah.
one.
Lots of people like to use their names.
Yeah.
So yeah, Stork was a German
Yeah, this
astronomer.
is Wilson 1 from now on.
Okay, got it.
And Markarian's famous for the Markarian's chain of galaxies.
Yeah.
A very famous grouping of galaxies, Markarian's chain.
So here is the double cluster up here.
Mm-hmm.
And this is the W of Cassiopeia,
Mm-hmm.
somewhere in there. 1, 2,
Yeah, Shedar, Calf,
1, 2,
Rukaba.
3.
Yeah.
Yeah. Oh, and there it's hidden behind the words.
Yeah.
Mm-hmm, mm-hmm.
So there.
Yeah,
And
the W kind of looks like
these are all
looks like a-
circumpolar.
Huh.
Let's see how we do that. Trying to see if I can get Polaris in the picture.
Okay.
I
Well,
think it
there-
might be too far away.
Yeah, there it is there.
There you go.
Right there. And so these are all things that go around circumpolar. So technically from our backyard, except for some hills behind my house, Cassiopeia is a circumpolar object and it never sets.
Mhm.
Every season of the year it's up, along with the Big Dipper. It's opposite the Big Dipper.
So this is always in the sky, just different places in the sky during the year, but it never goes away.
It's all circles around the North Pole.
And Australia can't see it,
No,
Depending.
depending on what.
If you're in far northern Australia, you might see it peak
Oh.
above.
Up there in their peninsula near
now this is a photograph. Moving on,
Lemon.
Comet Lemon taken by Adam Block
Mhm.
on Mount Lemon.
Mhm.
So he's not the guy that discovered the comet, but he has developed this new technique of processing images of comets. And this is his advertising topic. You can go to adamblockstudios.com and see his course of how to batch process pictures of the comet and get the comet to be right and the stars to be not blips or not streaks. So
That's just a fabulous picture.
he is the guy that I learned how to image process from back in 2009.
Yeah.
He's probably, in my view, either the best or one of the top 3 or 4 best
Yeah.
processors in the world.
For the
Mhm.
benefit of the two new watchers, why is it green or is it not green? Did he just add the green?
No, it's green.
Yeah,
That's fluorescence from diatomic carbon gas.
Really? Comes out as
Oh,
green.
carbon. Wow. Okay. Well, that's a beautiful image, Jerry.
Mhm.
Yeah.
Yeah, Adam Block's one of the best, like Terry said. It's amazing.
But we'll never see that in our naked eye. It's always requires a telescope, doesn't it?
yes. Well, some of them get close and you get a naked eye object. So here we're going to take a little trip to a planet inside the inside a globular cluster, because several times ago the Baron had asked what it's like to be on a planet inside a globular cluster. Is the sky really bright? And it's an easy calculation to make. It's numerically complex, but it's not a hard calculation. It just needs a big computer to figure it out. The globular cluster they chose is NGC 5927 inside of Lupus. And for us here, this is Lupus here in the south right now. And it's up with the sun. So it's more favorable to look at Lupus 6 months from now than right now. But this is as high as it gets. So it's a southern constellation. It's not really beneficial for us. So this is a Hubble photograph of that globular cluster. And it looks like a typical globular cluster. You can see that even the center here is resolved. So it's got a finite number of stars in it. And so they could model this star cluster numerically. And if you know the luminosity of each star, it's a lot of work, but you can figure out what the luminant flux is for an object inside the cluster. So there's a video, and I captured a few frames from the video showing us rapidly approaching the model of that globular cluster and starting to go inside.
Wow.
And then getting into the middle and looking for a sun with a planet on it. And finding in the middle, we're starting to resolve the stars. And this is the star we're homing in on. It has an exoplanet. And the exoplanet is a hypothetical exoplanet. There is no exoplanet that we know of in there. And the drawing of the exoplanet is purely hypothetical.
Right.
But this is what it looks like. This is the sun for that planet. This is outside the planet's atmosphere. And this is what the sky would look like with all sorts of very bright stars. And this is what it would look like inside the atmosphere during the daytime.
Oh, wow.
And so,
Really?
yeah.
And those stars are close enough to be seen, whereas in our case, with our atmosphere, we can't see any stars because they're too far away and too small. Is that
Not in this cluster, we can't see any stars, but we see a lot of stars. If from inside our atmosphere, there are an estimated 6,000 stars visible at some time, about 3,000 stars at a time in the hemisphere you're in. With an
not at the same time that our sun's up. That's what I'm talking about.
No, there you only see one star.
Yeah, right. So
And maybe a planet or two.
Yeah.
And the moon.
But these stars in the cluster we're looking at around their mother star are really closer than Proxima Centauri is to us.
No, they're probably closer than Proxima Centauri.
Which is 4.5 light years.
Yeah, but some of them are 4.5 light years away and still in this cluster.
Wow. So there'd be no night on this planet?
There would be a night, but it would be a brighter night.
Especially if there were a couple of moons.
Yeah.
Be rough being a telescope or a member of any astronomy club on one of those planets, wouldn't it?
Not too many astronomers.
That's a great.
Not a lot of happy astronomers.
Yeah.
No.
But they'd have a better theory of star formation.
Yeah.
Oh man, I tell you.
Better sunglasses too.
Yeah.
Yeah.
I'm sure there have been science fiction stories written about that very thing you just proposed. Can you go to the Mars Phobos trip around Mars?
Just a minute. Let me try and get this video going.
Oh, there's a video. I didn't see that.
There is a science fiction story that's on a similar vein to this called, I think, Nightfall. And it's a civilization on a planet that has in a 5-star system. So they never have a dark night.
Really?
But there's an astronomer that does an analysis of the orbits of the stars, and he realizes that they're all going to be, on the other side of the planet on this one day coming up. And so they're going to have night. And they're so used to always being in light that it drives people crazy who aren't indoors in a lit area.
Chuck,
the whole civilization collapses. But what they find is that every, 500 years or whatever, this happens, and they keep seeing these series of ruins as the civilization goes nuts and destroys itself.
That was a story on a Sirius radio and on their old time radio.
Can you see this video?
Yes.
Yeah. Yes.
Okay.
This is the planet you're talking about.
I captured a few still frames because I wasn't sure I could get this video running. It'll start again and then we can watch it. There, we going into the Milky Way, finding this globular cluster, entering the cluster, looking for our host star. Now looking for the planet. There's the host star, and there's the planet around it.
Oh, wow.
So this is what it would look like inside of a
those are mountains, not
cluster.
waves, right? That's not waves on an ocean. That's mountains. We're looking at it.
Yeah.
There was a little glitch as we were zooming in. There was a star superimposed on the planet.
That was tricky. There are a couple of stars superimposed, and when I did the frame capture, I had to avoid that.
Yeah.
Well, how do you suppose the Drake equation would tie in with the possibility of some life on one of these planets? Would it something be not there and it wouldn't work? Too much light in the sky, or too many companions nearby?
The one thing about globular clusters is they're mainly old stars and they're metal poor. And so you wouldn't have a lot of material for making a solid planet.
Really? But I'm sure that modern science, or astronomers these days, say that all the stars out there are probably similar to our solar system, and they all have asteroids in them. They all have Kuiper belts. They don't all have that.
Not all, no. The majority, but not all.
They can't see them, not even with the Webb. So why not? Layers of things we don't even have. You know, we have all these layers. There's the asteroid belt. There's the Kuiper belt, the shield. What's it called? The Oort cloud.
Yeah.
There's just a lot of stuff.
Many of them have similar features, but none are, none of them are automatically stamped copies of our solar system.
Yeah, well, there's probably a lot of things we don't have here. There's Phobos.
Okay,
I recognize that. One of the potato shaped.
No, this is hundreds of miles across, I think.
Oh, is it really?
No, not Phobos. Phobos is only like 13 miles across.
Okay. Well, this is Phobos, so 13 miles across.
And it's in an orbit that's decaying, so it's eventually going to crash into Mars.
Yes. So this was taken by the Mars Reconnaissance Orbiter.
Oh, that's an image.
Yeah. It's not an artist rendition.
How high up do you suppose it is?
Oh, I don't remember the height. It looks like it's about to crash here.
Yeah.
There was also this very dramatic picture.
Oh, Marinus.
Showing Marinara Valley's Marinara on Mars.
Their Grand Canyon.
Yeah. So this is also in orbit around Mars. Now we come to the
Saturnian moon, Iapetus.
Yes. Okay. It's this moon that it's half white, half dark, but it looks like a walnut. It's got this ridge around it.
Ooh.
Yeah.
12-mile high mountains.
Now this is from a Saturn moon?
This is a moon of Saturn.
Iapetus. Iapetus. How do you pronounce that? Iapetus.
Tom, what is Iapetus or Iapetus?
I think it's just Iapetus, John.
Okay.
Yeah.
Okay. Definitely sounds Greek.
So this is the ridge that goes around 75% of the girth along the equator.
Wow.
Certainly got enough
very dramatic pictures.
Enough craters.
Yeah.
Wow.
And you think that was from spin, Jerry?
What's that?
Do you think that ridge is from spin?
Well, here's the explanation for this explanation here. Another hypothesis was that there are a lot of really large impact craters there, that there was debris that formed a ring around it and then eventually came back down, fell back down. The ring is unstable, and you ended up with this pile of stuff.
This ridge.
Here's another view of what might have happened.
Yeah. This is what happens on ice over water, where two ice flows come together and collide. It creates a compression ridge, where material is when it runs into each other, it's forced up. This is how mountains form on the Earth with what do you call just below the crust?
Plate tectonics?
It's plate tectonics, but it's floating on the
mantle.
Mantle. Thank you. Good. Yeah. This getting old is getting dreary here. So so that's where our mountains come from. That could be where that happened, and it could be that the idea formed with ice around it, and then soil on top of the ice, and then over time the ice melted from internal heating, and it shrank, and so the crust experienced these compression flows and oriented to equator.
Your talking notes say that it only spans about what 75% of the equator.
Yeah,
There is a flat part then that didn't get
there is a
subjected.
place where that ridge does not occur.
Okay.
I'll be damned. But it's right on the equator. I mean, they can centralize, can't they? They can know exactly, like we know
Yeah.
exactly where the Earth's equator is,
Yeah,
equidistant from the North and South poles.
yeah.
And so it had a ring like Saturn that collapsed.
That's one explanation, but
Yeah.
this is another one.
Yeah,
Okay. Well, it looks like a lot of bricks fell.
and we're
from
not
heaven.
claiming this is the right one. We're
Yeah.
claiming this giving people things to think about.
Well, I've never seen a moon with a ring, so that's in the past. And this
Well,
is the
there are asteroids with rings, so
really?
yeah.
Yeah.
Well, I knew they had a little moon. And finally, that gave it to us, but I've never seen this on any other body in the solar system.
Oh, these ice flows, these flows are all over the ice moons of Jupiter, but they're localized. They don't go around the whole moon. But you can see compression ridges, and you can see the opposite of it when sheets of ice pull apart.
And there's water there underneath.
Underneath some of these things, there are oceans. No
And
one's
Iapetus is mainly ice, so yeah,
Yeah.
it could be there could be water there.
So the mountains are ice.
Yeah.
Wow. And we're going to go there to one of those moons, not this one. We're going to go to, which one is it? Europa?
We're going to
Yeah.
go to a lot of them eventually. And it's nice of nature to store lots of hydrogen up there for rocket fuel, lots of oxygen for us to breathe.
And lots of creatures under that ice covering that's swimming around.
That would be icing on the cake.
Yeah, well, hopefully, yeah. We'll see. And I got to tell you, a crack and a sail and a keel. Fantastic stuff.
Now this next bit, this James Webb picture, the cat's eye, is spectacular.
Yeah.
Yeah.
That's
So
not
this
what we're
is-
looking at, though, is it?
No, coming up.
Okay.
Yeah. So this is Ursa Minor. There's the pole star up there. So Draco is also a circumpolar object. It never really sets. This is the Cat's Eye Nebula in this bullseye. And this is a James Webb Telescope image of it.
That's unbelievable. Unbelievable.
Yeah.
I saw that in a horror
Always-
movie. It scared the hell out of me. Through my peephole in my door.
Now this is a planetary, correct?
Yeah.
Yes.
And this is the white dwarf that results that's left over.
Okay.
Good Lord.
Not doing any fusion. It's just coasting now.
Wow. This is all taken in the infrared.
No, this is taken in a combination of things,
Oh,
including the infrared.
but it's from James Webb, which operates in infrared. So they added what?
Yeah,
some-
it does. But it also operates in short wavelength and some visible.
But no radio waves below the
No radio waves.
spectrum. Okay. Fascinating. Jeez. Did we even know this existed before?
Oh,
sure.
yeah. Yeah, we've had pictures of it, but never this spectacular. This is just beautiful.
I mean, you
And
can
also-
see it. You can see it through a backyard telescope.
Right.
And it's called the cat's eye.
The cat's eye, yeah.
For you cat lovers. Okay. And we also got the horse head.
Yep. It's also
there
a
it
new
is.
one from James Webb. A lot of false color here.
That's a horse's head, or at least a pony.
Yep. Horse's Head and the Flame Nebula. So the Horse's Head is this dark nebula down here against a background of stimulated and reflected radiation.
Is that part of or close to the towers of creation?
No.
No, that's in the Eagle Nebula. This is near Orion. Just down to the right would be the Belt of Orion and the
Okay.
Sword of Orion and
Well, that star by the Flame Nebula there to the left of the horse head that the horse is looking at, that's one of the belt stars.
right. So the other one down to the right, and then below that would be the Sword, would be M42,
Yeah.
the giant emission nebula.
But you gentlemen with your scopes can never zero in on them to this degree, can you?
Not to this degree, but we can see these objects and photograph them easily. They're very photographic.
And they look like this. You can actually, it looks like a little horse head. It's not just a little black blip in the middle of space.
No, actually, through like Joe's telescope, an 18-inch scope, you can magnify this up and have it fill the field of view.
Yeah.
But it is, you need a really good night and a big scope to see it. And what helps is a hydrogen beta filter.
Yeah,
To enhance it a little bit.
yeah, and it's really dim.
Yeah, and the main part you see is the horse's neck there, sort of. It looks like a thumbprint. The rest of it is pretty subtle in a visual view.
A lot of imagination here.
Yeah.
This looks like part of Disney's Fantasia movie. It's so pretty. Like an astronomer's heaven. That's where we're all going to go when we die, and we're going to cruise the universe, gentlemen.
So when I was a kid in the 50s, we would go every month to the Griffith Observatory, to the planetarium show, because they changed it every month. But they always started the show with Debussy music of some sort. And so I've always associated these kinds of pictures of awe and majesty with Afternoon of a Faun or La Mer, something like that.
Yeah.
It showed that.
Well, like many Americans, I got my first introduction to this classics with Fantasia in 1939, and it opens with Bach, the Toccata and Fugue.
Yep.
And it's not a big organ.
The mad scientist theme.
Oh man, it's classic stuff.
Nemo.
Missing Bruce this week, but gentlemen, you did it again. I would just wish I could retain it all. And I hope you had good vibes across the turkey table on Thursday, gentlemen. Your wives all helped probably put together a great meal. And
oh yeah, now I'm trying to lose the weight I gained.
Yeah, I'm continuing on my beach ball diet.
Yeah, but you better eat those leftovers by tonight or they'll go bad, I understand. Me, I had hamburger helper on my own. That's what I had. And just real quickly, on Friday night, for the benefit of the folks, David Feinberg's going to talk about meteorites and tektites. I don't even know what tektites are. And Chuck's going to bring some of his, right, to display it on stage. Mm-hmm. And Rex Meach, our Ojai connection, is going to talk about celestial navigation, oversimplified. Mike Hardwick, longtime member, friend of mine, is going to do astrophotography and show us some of his beautiful pictures. And that's all our local in-house speakers for Friday night's big meeting at Fleischman Auditorium up at the Museum of Natural History. We'll convene here again next week, gentlemen. Thank you. You just dazzle me every time. So
thank you.
And we'll have our elections Friday night, too.